Hi guys, welcome to another video. In this video we'll be looking at logical equivalence. When two propositions have the same truth value, they are called equivalent. Now let's look at an example. Are the following logically equivalent? So we start by doing our truth table. So the two propositions that we're working with are P and Q. It is possible for us to use more than two propositions. So we have P and Q, and we start by taking all the possible combinations. So true, true, false, false, true, false, true, false. This ensures that all possible combinations are taken into consideration. Now, looking at what we're going to focus first on not P or Q. So in order to find the truth value for this proposition, we know what Q is, but we need to know what not P is. So not P. Now remember, not P is the negation of P, and it will take the opposite truth value of P. So here P is true. That means that not P will be false. Similarly, we'll have false, true, true. So it takes the opposite truth value of these guys here. So now we're able to find not P or Q. Remember, with the disjunction, once we have a true, well, one or two truths, then we know that the statement will be true. So it is not P or Q. So we have false or true. We know that this will be true. Similarly, we can apply what we know about the disjunction. I would get false, true, true to complete this part. Now we need to focus on the second proposition, which is the negation of P and not Q. So before we can find the negation of P and not Q, we need to find P and not Q. And before we can find P and not Q, we need to find not Q, because we have no idea what not Q is. So we'll find not Q, and you will see that not Q is false, true, false, true. So remember, it's just the negation of Q. So now we're able to find P and not Q. Remember, with the conjunction, this is only true when both are true. So we'll be looking at P and not Q. So it's the first case, it's true and false. So we know that's going to be false because it's only true when both are true. Next up, we'll have true and true. So we'll have a true here. We have false and false. So we have a false here, false and true. So we'll also have another false here. So now we're able to find the negation of this guy. So the negation of P and not Q. So we're just going to negate these. So we'll just change the truth values. So we'll end up with true, false, true, true. Now the two statements that we're interested in are those guys. Now look at the truth values. You'll realize that they are all the same. So true, true, false, false, true, 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 true. So they're all the same, and because it's the same, we can say that they are logically equivalent since they have the same truth values. That statement is very important. Alright, so don't forget it. Let's now look at another question. So are the following logically equivalent? So once again, we need to set up our truth table. So here we have the answer already, that it will be logically equivalent. They have the same truth values. So once again, we have all the possible combinations taken into consideration. So we have three propositions in this case we're working with, three simple statements, P, Q, and R. So we now have 4 truths, 4 false, then 2 truths, 2 false, and we repeat, then true, false, true, false. Alright, so doing this will ensure that all the possible combinations are taken into consideration. Now we'll focus on this statement here, P, R, Q, and R. So we need Q and R, so the conjunction of Q and R, so that will give us these truth values. Go ahead and pause the video to verify them, and with that we're able now to find P, R, Q, and R. So it's gonna be P, R, this. So by what we know about the disjunction, we will have these truth values. So having done that, we can now focus on the second statement, PRQ and PRR. So we break it down, we focus on PRQ. We need to know what is PRQ first, and we also need to know what is PRR, and then after which we can take the conjunction of both. So PRQ would give us these truth values, PRR would give us these truth values, and once again please feel free to verify for yourself that the truth values are correct. And now PRQ and PRR, so we're taking the conjunction of these guys here, would give us these truth values. We then compare the truth values of the statements that we want to prove are logically equivalent, and you can see that they are exactly the same. Now just a note, if we have any difference, then they would not be logically equivalent. So if we have, say for example, this is true and we have a false here, then even though that's also one thing, it still would not be logically equivalent. All of them have to be the same. Alright, and since they're all the same here, it means that the statement which came early is true. So these two statements are logically equivalent. So that's how we show, using truth tables, that two statements or two propositions are logically equivalent.